Hi, my friend. You're welcome again to Theophil Academy. In this session, I'm going to take you through the three types of equilibrium. These types of equilibrium, we have stable equilibrium, unstable equilibrium, and neutral equilibrium. I am going to start with stable equilibrium. What does it mean by the term stable equilibrium? We say that stable equilibrium is a type of equilibrium whereby a body returns to its original position after being slightly displaced. Now, I have come today with a body A. Consider this board. Do you see it? Consider this board. This board has one largest surface area, this which you see. And it has a smallest surface area, which is this one. Now, I am going to allow it to lie on each of these two types of areas, the largest surface area and the smallest surface area, and we see what will be occurring in each case. Let us start by displacing the body after it is lying on the largest surface area. Now, let us allow it to lie this way. Its base is the largest surface area. Now let us displace this body. After displacing this body, it means that I am going to attach it and move it in a certain direction. Now let me move it upward slightly. After being moved upward slightly, I am going to release it. When I leave it, you may see it has succeeded to return to its original position as it was. You have to remember, original it was this way. And after I have displaced it this way, after releasing it, it has returned to the original position. So it means that when this body rests on its largest surface area, it is stable. It means it has stable equilibrium. Now, if it is in stable equilibrium, so this tells us that a body will be stable if it rests on largest area. It means that its base must be the largest surface. Also, let us shift to a second type of equilibrium, which is unstable equilibrium. On unstable equilibrium, we say that unstable equilibrium is the type of equilibrium whereby a body does not return to its original position after being slightly displaced. Now, to elaborate this concept, let me use the same object A, this one. This is the same object as I used it to show the stable equilibrium. So, I am going to use the same object when we are going to verify unstable equilibrium. In case of unstable equilibrium, I'm going to allow this body to lie on the smallest surface area, this one. So it is going to be allowed to stand on this smallest surface area, and then we are going to displace it and see what occurs. Now, let me allow it to rest on its smallest surface area. I think you see it now. So, after allowing it to stand on the smallest surface area, I am going to displace it. When I am going to displace it, I just touch it and move it certain direction. Now, after moving it, I am going to release it. After being released it, I think you will see what will happen. Now, I am going to release it. Yes, I think you see. It has failed to return to its original position. As its original position was this way. It was this way. But after I have slightly displaced it, it has failed to return to its original position, and now it is seemed in a new posture. So, what does this tell us? This tells us that when the body rests on its smallest surface area, it will be highly unstable. So, for a body to be stable, it should have a largest base. But if the base is the smallest one, that object will not be stable. What this tells more? This is connected to the position of the center of the gravity. When this object during testing the stable equilibrium was this way, it means that here it is stable as its center of gravity is lowered, as you can see. But when this body it was this way, we have said that it is unstable because its center of gravity is raised. As you know, the center of gravity is located at the center. So if it is at the center of gravity now, it is around this part. So the height from the base is larger compared when it was this way. When it was this way, the center of gravity was lowered. So the height of the center of gravity was very, very small. That is why it is stable in this way. But in this way, it becomes unstable as the center of gravity is raised. So this is all about stable equilibrium and unstable equilibrium. Now let me shift to a neutral equilibrium. What is a neutral equilibrium? We define a neutral equilibrium that is the type of equilibrium whereby the height of the center of gravity of the body remains constant after the particular body is slightly displaced. Now, what does it mean? Let us verify this by using object B. This object is spherical, as you can see. It is a spherical. Now, I am going to position it on one side of the table, as you can see. So, at this, it is in a resting position. Now, I am going to displace it so as to set it into motion, and then I will see its posture after the motion, and it is where we will know that it is neutral or no. And if it is neutral, what criteria makes it to be neutral? Now, let me displace it. As you may see, I have displaced it. It is moving. Now, you can see this object, when it reached position B, its posture is the same as when it was at position A. This is due to the fact that you have to know this object is spherical. Now, if it is spherical, it means that from its center towards its circumference, the distance is the same. So, whatever the way you turn it, it will remain in the same posture. Now, all objects in which the height of the center of gravity does not change after being set in displaced, they are said to be in neutral equilibrium. So, all spherical objects are in neutral equilibrium. After that, let me draw different diagrams which show these three different types of equilibrium. For the stable equilibrium, we can draw this structure. The structure like this. This structure shows stable equilibrium. This structure shows stable equilibrium. Stable equilibrium. Why? As you can see, it rests on the largest base. As its base is largest in terms of area, it means that this object should be stable. So it is in stable equilibrium. To support this, when the body rests on the largest base, it means that its center of gravity is lowered. Its center of gravity is lowered. So the height of the center of gravity is low. For unstable equilibrium, we can reverse the first diagram. Unstable equilibrium. For unstable equilibrium, we can reverse the first diagram whereby it will rest on the smallest surface. So if it rests on the smallest surface, it will look this way. It will look this way. If it rests on this pointed end, it means that this posture, the center of gravity is raised. So for when the center of gravity of our body is raised, it means that its chance of instability increases. So this is in unstable equilibrium, as the slight displacement of itself will make it not return to its original position if we compare to the first structure which shows the body which is in stable equilibrium. The last structure is to show the occurrence of neutral equilibrium. Here I am going to use the ball or any spherical object to show neutral equilibrium. Neutral equilibrium. Maybe just take, this is a ball and it rests on the ground. As you can see, it rests on the ground. It rests on the ground. As I have demonstrated there, the center of gravity, this ball it means that it is located at its geometrical center. If it is at geometrical center, when you move from the center of this ball to any part of its circumference, it means that the distance is the same. So whatever you displace this ball, it means that at any posture you will find it at the new position will be the same as the original one, because its center of gravity, the distance from the center of gravity to any part on the circumference is the same. So I have said that for all bodies in which, when they are displaced, the height of the center of gravity does not change, they are said to be in neutral equilibrium. So a ball is in neutral equilibrium. Now, from these illustrations and demonstrations I have done, I hope the idea or the concept of unstable, stable, and neutral equilibrium are clear to you. Thank you for attending today's session. Welcome for the next sessions. Have a nice moment.